Hi everybody. Okay, so here we are. We're going to talk about parallelograms and trapezoids today. You already know a little bit about parallelograms. You did that homework on Monday, or that work in Khan Academy, hopefully. So our objectives today is I can use a formula to find the area of a parallelogram, and then I can use a formula to find the area of a trapezoid. I can recognize that a plane figure is made up of polygons, and I can solve problems involving areas of figures. So those are our objectives today. We'll talk about each one of those. Okay, why is it not moving? All right, so here we have a figure, A, B, D, E, and it's a trapezoid. You can see it has two parallel sides, a base of A and E, which is at the top, and a base of B and D, which is at the bottom. And the height is EC. So it runs between the two parallel lines, and it's perpendicular to both parallel lines. The diagonal BE of the trapezoid divides this into two triangles. So you see the blue one and then the pink larger one. On the next page it calls it orange. That's weird, right? Maybe I'm colorblind, I don't know. As you can see, both triangles have the same height because you have to have, right, this right triangle, the height has to be perpendicular to the base. So you have to extend this over and then go up to that highest point to create that perpendicular height, okay? All right. So the area of this trapezoid is the area of the blue added to the area of the orange or pink. So we're just adding, so here's our formula right here, right? And they've substituted AE for base, right? They've just, what the line is called. So half of the base multiplied by the height of the first triangle, the blue one, and then half of the base multiplied by the height of the second triangle. That's all a trapezoid is you're adding those two triangles together. So we have our formula shapes up as 1/2 of the height because both of them are being multiplied by the same height. And then we have the sum of the two bases, right? Because we were adding these two, we're adding the two triangles together. And so basically what they've done is they've factored out the height. They put it outside the parentheses, right? Because both formulas had a height in them. So we can take that out and put it outside of the parentheses. And they both had a half, so we factor that out. So what's left is the two bases. So that goes inside the parentheses. All right, so that's the sum of our lengths of our two bases. And here they've actually put those base numbers in. So if you counted the blue one, 1, 2, 3, 4, that's where the 4 comes from. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so then they just added those together and we get 1/2 multiplied by 5 multiplied by 14. And if you did that math, then you would get 35 centimeters squared. All right, so the parallel sides of a trapezoid are called its bases. We have base 1 and base 2. That's how they're referred to when you're writing your formula. And the perpendicular distance between the bases is the height of the trapezoid. The area of a trapezoid is 1/2 multiplied by the height multiplied by the sum of its parallel sides or its bases, base 1 and base 2. Okay, that's what it says right there, sum of its bases. So this is actually what your formula looks like. 1/2 multiplied the height, and then you see inside the parentheses we have base 1 and base 2. You can see that right here, right? Base 1 right here, base 2 right here. Now, does it matter which one we call base 1? Probably not, because we're adding them together. and we can switch, right, those. So that probably doesn't matter. Don't be overly concerned about which one you put as base 1 and base 2. Okay. And it says B sub 1 and B sub 2. That's how you read it. So you'd say 1/2 of the height multiplied by the sum of B sub 1 plus B sub 2. Sub as in like submarine underneath, right? Okay, so let's talk about how we could divide a figure into many shapes. All right, so pen ready, let's go. All right, so one thing we could do is we could divide this into a rectangle and a triangle, right? Or we could even do 3 triangles based on what information they give us, you know? Maybe they give us a base here and a height here, or maybe they give us this height and this base. Anyway, you don't know, right? They always try to give you lots of crazy configurations to try and solve, but try to look for the different things you can break a plane figure into. And sometimes that helps you solve a problem. All right, let's go forward. There are many ways you can divide up a trapezoid. Trapezoids are great shapes, right? Very versatile. So trapezoid ABDE is made up of a square, so all sides are going to be the same length, and a triangle, E, C, and D. And right here, all we know is C and D, and that's certainly not enough for us to solve this, so let's move forward and see if they give us a little more information. And they do. They tell us what the area of the triangle is. Now, we did some of these problems, so now we have enough information that we can actually solve this problem. So first thing we're going to do is we are going to solve for the area of this triangle right here. So we're going to write the formula because that's what we do first, so we can kind of organize our numbers. And we know that our area is 44, and we know that we have a base that is 11. So I'm going to put the numbers that I know in. I know my area is 44, and I know what my 1/2 is going to stay. I know I have a base of 11, and I don't know my height. Okay, so my next step is I'm going to take care of this fraction in this number. I'm going to consolidate them. I'm going to simplify, right? I don't want to be hanging on to that half. So I'm going to simplify that. So I've got is equal to 1/2 of 11 would be 5.5. So I'm going to write it like this, H. And then I would divide both sides by 5.5 or 5.5, right? And what you get here is this turns into the 1, right? And so it gives us the 1h left, because 5.5 divided by 5.5 is 1. 44 divided by 5.5 is 8. You'll just have to trust me on that. So now I know what this is. So I have this area, which is 44. And now I know that this, all these sides are 8. And the area for this, the formula for that is area multiplied by, the length squared. Because same as length times width, right? But they're both the same. So that's why we write it as length squared. So area is equal to 8 multiplied by 8, and that is 64. So instead of going back and using the trapezoid formula here, as you can see, by splitting it up, I can solve it. So I've got 64 plus 44 is equal to 108 centimeters squared. All right, let's move on. Okay, so now here we have a trapezoid, and we have kind of two trapezoids here. We have this big one, right? And they say that it is made up of a parallelogram, which is down here. And what we know about parallelograms is that both sides are the same, right? These opposite sides are the same. Opposite sides are the same length. So that's going to help us. And we have a triangle here, right? And then we have a square. So down here at the end is our square. So, and it tells us that the area of the trapezoid, this smaller trapezoid right here, right, this smaller one, without this square at the end, has an area of 99 square inches. So we have enough information to solve this, so let's do that. Let's solve this. Okay, so like I said, we are going to use this formula, right? The area is equal to 1/2 of the height multiplied by base sub 1 plus base sub 2. Okay, so base 1 and base 2. Well, here's our base 1, right? So let's put that in there right now. But what about our base 2? We have part of it. We need to come all the way over to here, right? But since we know that both sides of parallelogram are equal, right? These both have to be equal. We know that this is 8. So that added together, that would give us a length of 14 as our base sub 2, right? So let's put 14 here. So now we have both of our bases, and we know that the area of this smaller trapezoid is 99. So I have 1/2 of the height. All right, looking good. Okay, so let's simplify some stuff. And I am going to move some things around over here. First, I'm going to simplify this. 8 plus 14, that's going to be 22, right? So I'm going to move these things around. I'm going to put 22 up here by the 1/2, and I'm going to put the h here. My next step to simplify is I'm going to simplify this right here, right? I want to get rid of that fraction always, if I can right away. Okay, 1/2 of 22 would give me 11, h. And now need to isolate this h, right? Get it by itself. The only way I can do that is to deal with this 11. Dealing with this 99 isn't going to help me isolate that h, right? So I'm going to divide both sides by 11. This will make that become a 1. And this will become a 9. So now we know that we have a height of 9. And since we know that this is 9, and they told us that this is a square, we also know that this is 9. So we could go back and we could solve for the whole trapezoid, right? We could add 9 to 14 right here, so then we'd have a base of 23, and up here we'd have a base of 17. But that seems like some big numbers to be adding, and since I already know what the area of this is, I just think it's easier to solve for this area, right? So area, length squared, area is equal to 9 multiplied by 9. Area is equal to 81. So I've got 99 right here, plus this square, 81. And I can put this 1 over here to 99, that becomes 100, plus 80, so 180. So my trapezoid, so I'm going to write PQSV is equal to 180 centimeters squared. And we're done, right? Awesome job. can have a little practice with this today, not a lot, some more tomorrow. But I hope you enjoyed the activity today. Bye.